Today on the bench is part 2 of the tandyvision 1 gaming console. In part 2 of this video series, we are going to verify the overall physical condition of this gaming console's power supply. Let's begin by removing the top cover to expose the power supply PC board. The inside of the unit shows some dust and debris, but is relatively clean for its age. I plan on eventually disassembling the entire console and give it a thorough cleaning, but will refrain from doing this until the console is verified to be working properly. Let's start by looking at the assembly drawing for the power supply. The power supply generates 3 regulated voltages, plus 5 volts, plus 12 volts, and minus 2.1 volts. It also generates 2 non-regulated voltages, approximately plus 16 volts and plus 5.65 volts. Let's see what I measured for the regulated power supply voltages. Starting with the plus 5 volt regulated voltage rail, I measured 5.01 volts DC. For the 12 volt rail, I measured exactly 12 volts. Lastly, for the minus 2.1 volt rail, I measured 2.2 volts. Now we will see what I measured for the unregulated power supply voltages. Starting with the 16 volt unregulated rail, I measured 18.95 volts. Finally, for the 5.65 volt rail, I measured 5.80 volts. Zooming in on the power supply board, we can see 3 electrolytic capacitors, C1, C2, and C3. C1 is a 10,000 microfarad, 16 volt axial leaded capacitor and is the largest capacitor on the power supply board. C3 is a 2200 microfarad, 25 volt axial leaded capacitor and is the second largest capacitor on the power supply board. C2 is a 100 microfarad, 16 volt radial leaded capacitor and is the smallest capacitor on the power supply board. Now I know that there are people out there that will automatically change out all electrolytic capacitors without checking their condition first. I believe this method should be avoided unless the capacitors are actually bad and reforming them does not work. This is because it adds unnecessary cost where some of these larger axial leaded capacitors are very expensive, costing between $6 to $9 each, not to mention the additional time it takes to replace them. I will not waste time testing the C2 100 microfarad capacitor since it is a radial leaded part that is inexpensive to replace. Now I will show you what I did to verify the integrity of the 2 axial leaded electrolytic capacitors. We will actually focus on the 2200 microfarad capacitor only, since the method to check the 10,000 microfarad capacitor is the same. The first thing I did was to use my oscilloscope to measure voltage ripple across the C2 capacitor, which was 572 millivolts. Now, in order to verify that this is an acceptable voltage ripple, I used the following equation. This simplified formula for determining voltage ripple is a good enough approximation to use in these types of circuits. In order to calculate the voltage ripple, I did need to determine what the total current draw was for the supply that has the 2200 microfarad capacitor. Fortunately, the tandyvision service manual had this listed and saved me from having to physically measure it. Seen here, circled in blue, are the currents drawn from each supply. The supply with the 2200 microfarad capacitor supplies 0.275 amps, while the supply with the 10,000 microfarad capacitor supplies 1 amp. Knowing this information, I calculated the expected ripple voltage using the following simplified formula for voltage ripple. From this formula, I calculated the ripple voltage for the 2200 microfarad capacitor to be approximately 1.04 volts peak to peak. Comparing this calculated value to the measured value shows that we are well within the expected capacitor voltage ripple. This shows that the capacitor is properly acting as a smoothing filter. The next thing I did was to measure the out of circuit capacitance by unsoldering one lead from the power supply board. The capacitor measured 2,465 microfarads on my Fluke 179, which is well within its 20% tolerance. Normally, I would not measure a large value capacitor out of circuit. I ended up doing it this time because of the capacitor leakage current measurement that I needed to take. This type of measurement is done out of circuit. Finally, I measured the capacitor leakage current using my capacitor leakage tester that I had built earlier this year. I had measured a leakage current of 5 microamps for this 2200 microfarad capacitor, which is excellent for this capacitor type, value, and age. Therefore, this 2200 microfarad capacitor does not need to be replaced. I plan on testing out the rest of the console offline. If I find anything else wrong with it, then there will be a follow-up video. If you like this content, please do not forget to hit the subscribe button and give it a thumbs up.